12A. All right, so I haven't gotten any questions on section 8.2, but it's fairly early in the day on Thursday that I'm recording this, so most of you probably haven't gotten to that homework yet. If you have questions, please let me know and I will make a separate video for that, no problem. But we're going to move into section 8.3. We're only going to do 2 examples today. There are 4 examples in this section. We're going to break it up into a couple of days at least, okay? Not to say that it's horrible, but it's just a little longer today. So 8.3 talks about the distance between a point and a line. The distance between a point and a line. Wicket, what are you doing? Come here. Come here, buddy. Yes. Come here, Wicket. Come here. So, Wicket says hi. All right, so in example number 1, so we're going to show you what we're talking about here. In example number 1, it says determine the shortest distance from the origin. Whenever we talk about the origin on a graph, what we mean is this point right here, the point where the axes cross, which would be 0 and 0. All right? Now they want to know the shortest distance from that point to the line y is equal to 2x minus 10. So the line 2x minus 10, so there's quite a few skills you have to know in this. First skill, yes, there's a kitty, she just came out. The first skill that you have to know is how to draw a line. So if this is in y is equal to mx plus b form, which it is, my y-intercept is negative 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my slope is 2 over 1, which means I go up 2 and over 1. So up 2 and over 1. So here's my line. If you put the line in the wrong spot, as long as you do the math right, it doesn't really matter. Anyway, as long as you do the math right, it doesn't matter, but for me, it helps to draw it. So they want me to determine the shortest distance from this point to this line. The shortest distance from one place to another is always a straight line. If I was able to drive my car to school without making any turns at all, I would get there the fastest. The problem is that there's like trees and a river in the way, so I can't. So when they build roads, they have to put curves in the road because they have to move around things. If you go to the prairies, the roads are very, very, very straight. And I don't know if you've ever heard the term as the crow flies. As the crow flies means in a straight line, because a crow is likely going to fly straight from point A to point B. It's not going to go all over the place because it doesn't have anything in the way. So the shortest distance from this point to this line is going to be a straight line. And it's going to be like not a line that's crooked. It's going to be completely, I didn't draw that very well. It's going to be completely perpendicular to that line. The shortest distance is a straight line that is perpendicular to the line you drew. Okay? So, what I need to know is I need to know the length of this blue line, because that's the distance. The length is the distance. Right? Right. So, if I want to do the length of a line, at some point, I'm going to have to do the length of a line formula, which is x2 minus x1 squared plus y2 minus y1 squared. Now, I have the beginning of the line. 0 and 0. So we'll call that x1 and y1. Here's the thing. I don't know the point where the end of that line is. We'll call it my x2 and my y2. And I need that in order to be able to figure out the length of that line. So there's some steps I have to do before I can go to this. Okay, if I put you down, will you spin? Don't spin. We're working on not spinning. You wouldn't think that that would be a difficult task, but apparently it's very hard. Okay, so we need, our goal is to figure out what this point is so that we can use it in that formula. That's our goal. Okay, so here's the thing. I know that this point, it is on this black line. It is also on the blue line. It is the end of the blue line and it's sort of in the middle of the black line somewhere. But it is a point that is shared, that is the same between this line and this line. So if I could go all the way back to chapter 1, where we talked about solving systems of equations, what I actually need to do is I need to solve a system of equations. I need to solve what value of x and what value of y would be both on this blue line and on this black line. Well, there's a problem with that. I don't know the equation for that blue line, but I can figure it out. Somewhere, way back, I think it would have been in grade 10, you learned how to find the equation of a straight line. Lay down, Wicket. Good boy. You learned how to find the equation of a line. So let me refresh your memory, or just teach you from scratch. I don't know which it is, all right? If you want to find the equation that goes with this line, we know the equation that goes with the black line. It's y is equal to 2x minus 10. But what equation goes with the blue line? There's a way to figure that out. And here is what it is. We do y minus y1 is equal to slope times x minus x1. And I have an x1 and a y1 for the blue line. It's 0 and 0. This y and this x don't have a little number, subscript. So we just leave those as letters. We don't change that. So we're going to have y minus 0, and we're going to have x minus 0, because that's my x1 and my y1. My slope, however, how do I know what that slope is? Well, the fact that the blue line is perpendicular to the black line is important information, because if the blue line is perpendicular to the black line, and what do I know about perpendicular slopes? I know that they are negative reciprocals of one another. So I know that the slope for the blue line is going to be the opposite sign to what this is. So this one was positive, so this one's going to be negative, which makes sense because the line's going down, which means it should be a negative slope. And it is the reciprocal of this. So instead of 2 over 1, it's 1 over 2. Now you say that looks very confusing. You're right, it does. But y minus 0 is just y. And this would be negative 1/2 times x. That's the equation, because here's my slope, so mx, and my b is actually 0, plus 0, right? Because the y-intercept is at 0. So that's actually the equation, and you don't need to put the plus 0. If you do, it's not wrong, but you don't need it. So this is the equation for the blue line. So this is the blue line equation. That is the black line equation. Okay. So how do I go about solving for this? So let's think back, way back to September when we were doing solving systems of linear equations. If I gave you two equations, and you have two equations, you have y is equal to 2x minus 10 and y is equal to negative 1/2 x. If I asked you to solve that, you could solve it by graphing, which I sort of have here, but I would have to be really guessing at what that is. Or I could solve by substitution, or I could solve by eliminating one of them. And honestly, it's up to you. But here's how they do it in the textbook. Here's how I do it. If y is equal to negative 1/2 x and y is also equal to 2x minus 10, I'm going to do substitution. If y is negative 1/2 x and I have y is equal to 2x minus 10, but y is negative 1/2 x, I'm going to replace this y with negative 1/2 x. In essence, what I'm doing is I'm making this equation equal to this one. They're both y, so they're equal to one another. Now I can solve this. If I move this over here, I have negative 1/2 x minus 2. That's negative 2.5, which would be negative 5 over 2x. If you like decimals better, put negative 2.5. It's fine. Is equal to negative 10. So I would multiply this side by 2, so that my 2's cancel. So I multiply this side by 2. So I would have negative 5x is equal to negative 10. Divide both sides by negative 5, and I would get that x is 2. So this point is 2, and now I need the y value. Well, I can either take that x value and I can put it into here and solve, or I can put it into here and solve. You should get the same answer. If I put 2 into here, negative 1/2 times 2 is negative 1. I think. Negative 1/2, yeah. Negative 1/2 times 2. Let me just make sure I got that right. Did I do that right? No, x is 4. Hold on, x is 4. What did I do wrong? 5. If I bring this over here, that's negative 2.5, which is negative 5 over 2. Oh, because this would be negative 20, duh. 10 times 2, 20. You were probably yelling at me. Divide both sides by 5 and I get 4, not 2. That's the problem. I get 4. So this should be 4. Sorry. So if my x is 4, if I put it back into here to figure out what my y is, negative 1/2 times 4 is negative 2. If I chose to put it into this one, 2 times 4 is 8. 8 take away 10 is negative 2. I get the same answer, so it doesn't make any difference which one you decide. If you decide to go back to here or back to here, it doesn't matter. All right, so now what I've done is I have figured out the beginning of this line I knew was at 0 and 0. Now I know the end of this line is 4 and negative 2, which means I can figure out the length of that line because I have an x1 and a y1 and I have an x2 and a y2. So I can figure that out. So I can do my length of my line is x2 minus x1 squared plus y2 minus y1 squared. Wicket, lay down. Which is 4 squared, which is 16. Negative 2 squared is 4. So this is the square root of 20. By the way, they said round the answer off to the nearest tenth, which it ends up being 4.5. So the length of this line is 4.5 units long. So let me recap what we did, because it's going to be the same steps every single time, just with different numbers. So they give you a point, they give you a line. You know where the line starts, you need to figure out where the line ends. So the first thing you have to do is figure out the equation for this blue line here. You do that by y minus y1 is equal to slope times x minus x1. Where the y1 and the x1 are, you put your x1 and your y1 in there. For slope, you take the negative reciprocal of the slope you have for this equation because the two lines are perpendicular. Once you have that new equation, y will equal this, y will also equal that, so that means the two equations are actually equal. You then solve for your x, substitute back into either equation to figure out what your y is. That gives you the end of your line, so you can do the length of the line formula. So we're going to do another one. So example number 2. And this is the only other one we're doing, okay? Example number 2 says, find the distance from the point -1 and 3 to the line x plus y equals, minus 5 equals 0. So, and they want us to round it to the nearest hundredth, which is never a good sign. So the first thing I like to draw it. It just helps me visualize. There is no need. There's no necessity to draw it if you don't have to. I like to do it to help me and to help some of you who are a little bit more visual. So the point that I have is -1 and 3. So this is my point, -1 and 3. Now the equation of the line is not in y is equal to mx plus b form, but that's not a big deal because I can get it there. I just isolate my y. So I move my x over to be -x. I move my -5 over to be +5. So that means my slope is -1 over 1. So my y-intercept is 5. 1, 2, 3, 4, 5. And my slope is down 1 and across 1. I always go to the right, but depending on what the sign is, I either go up or down. Because it's negative, I'm going to go down 1 and across 1. So here is my line. So they want to know what is the shortest distance from that point, from this point to this line, and it will be a perpendicular line. So the beginning of this line is at -1 and 3. So I'm going to call that my x1 and my y1. I need to figure out my x2 and my y2. So I need to first step. So for those of you who like things in steps, step number 1, find the equation of this blue line. Find the equation of the line. Equation of a line is y minus y1 equals slope times x minus x1. So my y1 is 3, so y minus 3. My x1 is -1, so x minus -1 would actually be x plus 1. My slope is the negative reciprocal of the slope of your black line. So if I flip this over, it's still 1 over 1, and if I change the sign, it's positive. So my slope is actually +1. So I would have y minus 3 is equal to 1 times x is x, and 1 times 1 is +1. Sorry about that. So I'm going to move the 3 over here, and I'm going to have y is equal to x plus 4. So now, step number 1, find the equation of the blue line. Done. Step number 2, if y is equal to this, and y is equal to this, that means that those two equations are equal to one another. So that means that x plus 4 is equal to negative x plus 5. I make them equal to one another and I solve. So I'm going to move this over here. So x plus x will be 2x. I will move this over here, so that would be minus 4. So 5 minus 4 is 1. So x is a half. Part of the reason why I like to graph it is because I like to know, does that make sense? And based on what I've drawn here, it does make sense. That does look like that's over about half a square. So the y does seem to make sense. The x does seem to make sense. Now, I need to figure out the y. You can either put it back into this equation and do 1/2 plus 4. That will give me my y, which would be 4.5. Or I could put it into here, which would be negative 1/2 plus 5, which would still be 4.5. See, it doesn't matter which one you put it back into, because you'll get the same answer. I get 4.5. Now, if you would rather, that's 9/2. If you would rather have it as a fraction, it doesn't make any difference to me at all. All right, so now that I have this point, okay, step 1, find the equation of the blue line. Step 2, make the two equations you have equal to one another, solve for x, and figure out the y. So once you have the beginning of the line and the end of the line, now it's a matter of putting this in. So the square root of x2 minus x1. So 1/2 minus negative 1 squared. So that's really 1.5 squared. Plus y2, which is 4.5 minus 3 squared. And so I just put that all into my calculator. It turns out it is 2.12. So the length of this line is 2.12 units long. All right. So I've given you the steps. Step 1, find an equation for the blue line. Step 2, make the two equations equal and solve for x and figure out your y. Step 3, use the beginning point and the end point to figure out the length of the line. 3 steps, same steps every single time. Like I said, I have a tendency to draw it just so I can see when I figure out this point, does it even make sense? But you don't have to do that. That's just something I do, for me, but also for you. All right, I will list a few questions for you to try. Let me know how those go. Make sure that you are uploading your homework into Google Classroom. If you still don't know how to do that, please contact me and tell me that so I can hopefully walk you through the steps or direct you to someone who does know how to do it. My screen on Google Classroom looks very different from your screen on Google Classroom. So when someone says, how do I? It's kind of a hard question for me to answer because I don't see what you're seeing. I see something very different. But I can certainly get you in contact with another student who does know how to do it, and they can hopefully talk you through it if I can't help. All right, so have a good weekend.